Good afternoon, everyone. Welcome to our presentation. Today, I am going to discuss about the project on wireless domain called Design of Dual Band Body Area Network Antenna using CST. So, my teammates are Harika and Anup, and we did this under the guidance of Arun Vignesh sir. Let's get started. Our paper discusses on wearable antenna, which is proposed for wireless body area network frequency range. This antenna is designed as a button antenna with a diameter of 14.52 mm using computer simulation technology. So the main aim of this is to operate at the dual band, that is nothing but the multiple frequencies called dual frequencies. The main objective is to design a button antenna for wireless body area network applications for 2.45 GHz and 5 GHz frequency band using computer simulation technology for establishing short-range communications. So nowadays, wireless communication offers many opportunities for people to share information with one another at any time and from any location. It became an important part of life. From home to work, everything is wireless. Every work included with technology is becoming part of wireless domain. The devices for the home, business, and other information devices that can connect wirelessly in short range have been receiving greater attention as the desire for ubiquitous network has grown. Monitoring health of a patient, analyzing health records of an athlete, tracking of a person, and many more applications can be achieved through wireless networks. A button antenna is designed for this network. To overcome the difficulties of totally woven antennas, button antenna is designed. This is achieved through computer simulation technology. Computer simulation technology, the use of a computer to represent the dynamic responses of one system by the behavior of another system which is modeled after it. Designing, executing, and analyzing are the three main steps in a computer simulation technology that a user follows to design the required component. So let's get into proposed antenna design. So this antenna is composed of a dielectric button which is located above textile substrate with a conducting textile ground. Practically, the textile substrate and ground are incorporated into in them of clothing. The export models have a PVC ground instead of a conducting textile ground can be modified in the relevant export models if it is necessary. So the substrate here used is Rogers 5880. The underside of the button has a metallic part with tuning stuffs. This patch is directly fed by the center pin of the coaxial cable mounted below the PVC ground plane. A circular metallic patch with cutouts is present on the top of the surface of the button of dielectric and it is short-circuited to the ground through use of wire. Both wire and the center pin of the coaxial cable are used as stable base to maintain the air gap between the button and the bottom substrate. Capacitive feeding is used to excite the upper surface patch element. These are the formulas we are used in our design. So this is the antenna which we have designed in the CST. So this is the antenna top view where we can observe all the circular metallic parts and all. And this is the antenna side view and this is antenna side view as well. Radiation patterns. So this is the radiation pattern for 2.45 gigahertz and 5.2 and 5.8. As we discussed earlier, the topic is design of dual band. That means operating at the multiple frequencies like 2.45 gigahertz and 5.2 and 8 gigahertz. So dual band performance is achieved with different radiation patterns in each band. This allows for different operating modes for a single antenna. In the lower 2.4 gigahertz band and quasi-monopole type, the pattern is radiated. We have the directivity values from the CST. So we may determine the antenna gain using the formula gain equals to directivity into efficiency based on this data. So the antenna for 2.45 gigahertz has a directivity of 2.7 decibels with 80% efficiency. And for 5.2 gigahertz, we have a directivity of 5.5 decibels with 89.7 efficiency. And for 5.8 gigahertz, we have directivity of 5.7 decibels and 91.4 efficiency, making it compatible for the 2.45 and 5 gigahertz bands. Total gain for the radiation patterns 2.45, 5.2, and 5.8 gigahertz is 1.9 decibels to 5.3 decibels. So these are the S parameters which we are obtained from the model. So VSWR, it is nothing but voltage standing wave ratio, which evaluates the efficiency with which radio frequency power is delivered from a source to a load over a transmission line. A lower VSWR value indicates that better power is reaching the antenna. A VSWR value of less than 2 is considered adequate for most antennas. So we can observe the VSWR's graph where the x-axis is plotted with the frequency and y-axis is the VSWR. So we can conclude a dual band button antenna is designed using CST for wireless body area networks, which works at two frequency ranges 2.45 GHz and 5 GHz. The radiation patterns, S parameters, and VSWR of the antenna are evaluated. The size of the antenna matches the criteria for W band applications. Thank you.